All right, 3.8. Multiplying and dividing by monomials. In order to multiply a monomial by a monomial, you need to multiply the coefficients, multiply the variables using exponent laws, and an example to show that we will see here. Example 1. 30x times 44x cubed. B, negative 6xy times negative 5z squared times 2x squared y cubed z4. So, sorry, hold on folks. All right, so what we're going to do is multiply these two monomials with each other. To multiply monomials, we need to multiply the coefficients. So notice that it's all multiplication between here. So the idea is we can multiply 30 times 4 to give us 120. We can multiply x times x cubed, which gives us x to the power of 4. Why is it to the power of 4? Because there's 1x here and 3x's here. When we multiply x times x times x times x, that gives us x to the power of 4. All right, and this is the question simplified. Let's look at the next one. Here we have 3 terms being multiplied. What do we do here? Well, it's all multiplication, so we can go ahead and just multiply all the variables, all the coefficients. So, the coefficients are negative 6, negative 5, and 2. So we're going to multiply them. Negative 6 times negative 5 times 2 gives us 60. X times x squared gives us x cubed. Y times y cubed gives us y to the power of 4. Z squared times z to the power of 4 gives us z to the power of 6. So one more time, we combine the coefficients to give us 60. We combine x times x squared to give us x cubed, y times y cubed to give us y to the 4, and z squared times z to the power of 4 to give us z to the power of 6. All right, let's look at another example. Now, in order to divide a monomial by a monomial, you must divide the coefficients and then divide the variables using exponent laws. So again, we're going to simplify, but this time with division and multiplication. So here's an example. Negative 8x to the power of 8 times y to the power of 5 times z to the power of 6 divided by 12 times x to the power of y, x times y times to the power of 3 times z to the power of 2. We're going to divide these. And we're going to divide this one. All right, here we go. Negative 8 over 12 gets reduced to negative 2 over 3. X to the power of 8 over x gets reduced to x to the power of 7. So the idea is you have 8 on top, 1 on the bottom. When you divide, you subtract the exponent, so that gives us 7 on top. Y to the power of 5 over y to the power of 3, that gives us y squared on top, y to the power of 2 on top. There's 5 on the top, 3 on the bottom, so 3 disappear, you're left with 2. Z to the power of 6 divided by z squared, well, we have 6 on top, 2 on the bottom, so 6 minus 2 gives us z to the power of 4. And that's the answer for part A. Part B. Part B is a little tougher because we have some extra stuff we have to do. Let's simplify the numerator first. That is, 2m squared all cubed becomes 8m to the power of 6 times n to the power of 5. Now, some of you might be wondering, why is it m to the power of 6? Well, 2m squared cubed actually means 2m squared times 2m squared times 2m squared. And when you multiply all of that, 2 times 2 times 2, that gives us 8. M squared times m squared times m squared gives us m to the power of 6. Now, we have n to the power of 5. That's still in the numerator, folks. And on the denominator, we don't have to change anything. Our denominator stays the way it is. Now, we can simplify. We simplify by taking 8 divided by 4. That gives us 2. M to the 6 over m to the power of 4 is m squared. And n to the power of 5 divided by n cubed gives us n to the power of 2. So we're left with 2m squared n squared. All right, another example. In order to divide a polynomial by a monomial, we need to be careful and divide each term of the polynomial by the monomial in the denominator. So it's very important that we follow this rule. So here's an example. 9x plus 6. How does that simplify? Well, the way I tell students, let's go back. Sorry about that, folks. Let's go back to this. 9x plus 6 all over 3. What does that mean we do? Well, we take the denominator and we give it to each term in the numerator. And that only works when it's a polynomial divided by a monomial, folks. It doesn't work if the denominator was anything larger than a monomial. So, 9x plus 6 turns out to be 9x divided by 3 plus 6 divided by 3. So you divide each piece. Once you do that, you simplify it to give you 3x for the first part plus 6 divided by 3, which is 2. 3x plus 2. Next, we have 24m to the 5 minus 9m cubed over 3m squared, negative 3m squared. When we simplify a question like this, what we need to remember is that we take each piece of the numerator and divide by that monomial in the denominator. So each of these will get the same denominator. So 24m to the 5 over 3m squared. Now remember earlier I gave you a rule about negatives. Negatives are never allowed in the denominator. If they appear, we move it to the numerator. So instead of leaving it down here on the bottom, I just automatically moved it to the top. Next we have this minus that was here, and minus 9m cubed divided by negative, remember the negative moves to the top, and then 3m squared. Remember that negatives are not attached to a number, they're actually attached to a side. They should be moved to the top immediately. Next, when we simplify this, we get negative 8. That's 24 divided by 3 is 8. It's a negative, so negative 24 divided by 3 is negative 8. M to the 5 over m squared gives you m to the power of 3. Plus, and why is it plus? Because this minus minus turns into a plus, and 9 divided by 3 is 3, and m to the power of 3 divided by m squared just gives you m. And that, folks, is the end of question B. Let's try another example, and a little bit harder here, folks. So let's give you a big trinomial divided by a pretty big monomial. What do we do here? Well, you take the denominator and you give it to each term of the numerator. So we get 25k cubed, w5 over 5k squared, w squared, minus 20k5 w cubed over 5k squared w squared plus 5k squared w squared over 5k squared w squared. All right, so what we did, recap, we took the denominator and gave it to each term in the numerator. That only happens when it's a polynomial divided by a monomial. Next, we simplify. 25 over 5 is 5. k cubed divided by k squared is k. W5 over w squared is w cubed. Minus 20 divided by 5 is 4. 20 divided by 5 is 4. K to the power 5 over k squared is k cubed. W cubed over w squared is just w. And then plus 5 divided by 5 is 1. That's right, it's 1. And all of these k's and all of these w's is canceled away so that we have the answer 1 on there. So the numerator is the same as the denominator. Remember, it's the same example as 5 divided by 5. The answer is 1. So this is the final answer to this problem. All right, folks, that's the end of the lesson. Have a numerical day.